Hi folks, this is Checkpoint Quiz 5.3. Number 1, we're asked to solve a nonlinear inequality. Nonlinear meaning that the powers on the x's here are something other than 1. And so the way we're going to solve this is the way we've solved all of these nonlinear inequalities. Get everything on one side, 0 on the other, make a sign diagram. So I'm going to move the x to the 2/3 and 12 over to the left hand side with the x to the 4/3. So I'm going to have x to the 4/3. I'll be adding x to the 2/3 to both sides and subtracting 12 from both sides, and that'll get something less than or equal to 0. I'm going to call the left hand side of this f of x. So I need to find where the f of x is equal to 0 or the f of x doesn't exist. So let's check out the domain of the function first and see if there's any issues with that. Because we do have fractional exponents, that means the denominators here represent roots. But what roots do they represent? Well, an x to the 4/3 power means that we're looking at a cube root of x to the 4th. And the x to the 2/3 power means we're looking at the cube root of x squared. The cube root's defined for all values of x, so we don't have any domain issues at all. There's no denominators, and the radicals involved have an odd index, so everything's fine with that. So our next step then is to look where the f of x is equal to 0. So I set x to the 4/3 plus x to the 2/3 minus 12 equals 0. And the tricky bit about this is I have two different exponents here, and they're being added. The bases are being added, so there's no property of exponents I can use to help me out here. So I fall back and I look and notice that we have 3 terms, and the exponent on one term is exactly twice what it is on the other. That tells me this is a quadratic in disguise. So I'm going to let u be x to the smaller exponent. Then that means u squared is going to be x to the 2/3 squared, which is x to the 4/3. And so in the land of u, the equation x to the 4/3 plus x to the 2/3 minus 12 equals 0 turns into u squared plus u minus 12 is 0. This is a friendly quadratic equation. It factors nicely. U plus 4 times u minus 3 equals 0. And from this factor being 0, I get u equals negative 4. And from this factor, I get u equals 3. And now, as I like to say, you've solved it for you. Now you got to solve it for me, and I want to know what the x's are. So I go back to my substitution. X to the 2/3 is either negative 4 or x to the 2/3 is equal to 3. To solve these, I convert them back into radicals and exponents. So x to the 2/3, I can write that one of two ways. I can write it as the cube root of x squared, or I can also write it as the cube root of x, then squared. It really doesn't matter. I think most students write the power first, then the radical. So if I were to solve this equation, I would cube both sides to get rid of the cube root. So I would have x squared then equals negative 4 cubed is negative 64. And to solve this, I would extract square roots, plus or minus square root negative 64. This gives us no real solutions. Okay, so we don't care about the imaginary solutions here in section 5.3. I go back to this equation then, x to the 2/3 equals 3, and I rewrite that. Follow the same procedure. I'm going to cube both sides. I get x squared equals positive 27. Extract square roots. I can simplify the square root of 27 as the square root of 9 times 3, so the 9 comes out 3 square root 3. Okay, and it's a good exercise to take these and actually substitute them back into my original equation, which is over here, to check that plus and minus 3 square root 3 actually do make this equation true. Okay, so we'll leave that to you to do. The point is, these are the numbers that go on the number line when we create our sign diagram. Okay, so we're going to go make our sign diagram now for our function f of x. And the critical values we had were plus or minus radical 27, which is plus or minus 3 radical 3. We'll have negative 3 radical 3 and 3 radical 3. Those were the places where the function was equal to 0. So we'll put zeros up there. And now what we want to do is check around these points. So a favorite test value between these numbers is going to be 0, because that'll be easy to plug in. What other test value should we pick? Well, the square root of 27 is going to be bigger than the square root of 25. So this is plus or minus 5 point something. Okay? But looking at what we're plugging it into, we're plugging it into things like x to the 4/3, x to the 2/3. That denominator, remember, indicates a cube root. So we would like to put in perfect cubes. So 0 is going to work fine. But what would be a good perfect cube to stick in here? Well, I need a perfect cube less than negative 5, so negative 8 works pretty well. And a perfect cube bigger than 5 is going to be 8 as well. So we'll plug those in. F of negative 8. And let's see, I'm going to have negative 8 to the 4/3 plus negative 8 to the 2/3 minus 12. So this denominator of 3 means cube root. The cube root of negative 8 is negative 2. You raise that to the 4th power, you get 16. The cube root of negative 8 is negative 2. Raise that to the 2nd power, you get 4 minus 12. And this is a positive number. You plug 0 in. 0 to any power is 0. So we get a negative 12 out, which makes it negative. And then I plug the 8 in. Well, this is another example of where we're going to have an even function, because you take the cube root of 8 to the 4th power, you're going to get the same thing as you got over here, because this is 2 to the 4th is 16, 2 squared is 4 minus 12. F of x is actually an even function, so we're going to get the same positive number out here we got at negative 8. So what's our final answer to this problem? I was looking for where this was less than or equal to 0. So I'm looking for negatives and zeros, and that happens between negative 3 square root of 3 and 3 square root of 3, including the endpoints, because we're allowing equality. That'll do it for number 1.